Now we are on 18.25. We're given a circuit with 3 resistors and 3 batteries. We are asked to find the current in each resistor. Find the current and the potential difference between points C and F here. So we want the potential difference here, and we want the current here. So this is another Kirchoff's rules problem. Okay, so we need to define which directions the current is going. We have, we have this 80 volt battery here. We have a 70 volt battery here, and then we have a 60 volt battery here. So I would assume that the current is going to be going this way and then down. Okay, so let's draw it like that. That's what we're going to do. You can choose any direction for the current, but I like to keep it physical if I can. At least that's my assumption, that it's going to be going that way. So let's do this. Let's go here. I think I already put it. Yep, I sure did. So okay, look. So this is going. So this direction, and here. So that gives us 2 solid loops of current, which makes sense. Okay. And so we can also look at this as the current travels from I2. We'll call this current 2. I2 is going down this way into this junction. It's going to come outwards into what we'll call I3, and I1 going this way. So I2 is equal to I3 plus I1. So that will be our first equation that we can use. I2 is equal to I1 plus I3. Using Kirchoff's first rule. All right? Great. And so now we can sum up the potential differences going around 2 loops. So we have 1 loop and 2 loops here. We're going to need 3 different currents. So we have 3 unknowns, 1 equation so far. We're going to need 2 more equations we get from each loop. So let's go to loop A, B, C, F, right? And then start summing the potential differences. So going, let's just go this way. Going this direction, from negative to positive, for E1 is going to be positive. So positive E1, and then we keep going around the loop this way. We're going to come down here with current 2. We're going positive to negative. That's going to be a negative EMF, negative E2. And we continue going down, going with the current 2 through the resistor. That's going to be negative R2 times I2. And then we have the same thing happening here, going with the current through the resistor. That's going to be negative R1 I1. This is all equal to 0. So the only positive that we ended up with was E1. And in the problem, if you look, this is going to be 70 volts minus 60 volts minus I2 times, what was R2 was 3 kiloohms, and minus I1 times 2 kiloohms, all equal to 0. Great. So 10 volts is equal to 3 kiloohms. I'm just rearranging a little bit. I2 plus 2 kiloohms, I1. It doesn't really matter how we rewrite this. That's pretty much what we're left with. So this is going to be equation 2. Equation 2. Equation 1, equation 2. Now let's go to the next loop. It's going to be C, D, E, F. So these discussions probably are more helpful if you are following along in the book, because I just can't keep these diagrams up the whole time as I'm going through the math. Okay, so now we have, Well, let's go back to it anyway. So now we're going to go, let's say, this direction. Yeah, it doesn't really matter. As long as we're consistent, it should be fine. So we're going to go against I2 through R2. It's going to be positive. So that's positive I2 R2. Then we're going negative to positive through E2. That's positive. EMF2. And then we go through here against the current through R3. That's positive as well. And then we're going to go from positive to negative through the battery this way, through E3. That's a negative. And that is all equal to 0. Yep. Okay. So then, again, looking at the diagram, we've got, what do we have? 60 volts minus 80 volts plus R2 was 3 kilo ohms, I2 plus 4 kilo ohms, I3. This is all equal to 0. So then we're going to end up with 20 volts is equal to, just bring this down here like that. Right, because this is negative, but we take it to the other side. And so this is equation 3 now. So now we have 3 equations. So just duplicate this again. I don't know why I don't do more of this. It's very easy. Here's equation 2. And then we had equation 3 here. So now this is the system we need to solve to find these 3 values. Okay, so it's pretty much just like the problem we did before, the really long one. I think that was problem 23. So let's see. Let's do this. Let's take the units because we have kilo ohms. Let's take the kilo ohms over volts. So remember that a volt over ohm is going to give you an amp. But a volt over kilo ohm is going to give you a milliamp. Okay? So then we're just going to we're just taking the units to the other side to make things a little easier. So what that means is we have 20 milliamps is equal to 3I2 plus 4I3. That gives us 10 milliamps equal to 3I2 plus 2I1. And then, again, that just simplifies things a little bit. Okay. So if we look, we have I2 in this equation, we have I2 in this equation, and I2 in this equation. I think it'll be easier if we solve for things in terms of I2. So let's do this first one. So we'll say I3 is equal to let's do 20 over 4 milliamps minus 3 over 4 I2. Right? And then I1 is going to equal, taking this to the other side, 10 over 2 milliamps minus 3 over 2. It was 3 over 2 I2 in terms of milliamps. So this actually is 5 milliamps minus 1.5 I2. This is going to be 5 milliamps minus 0.75 I2 because 3 over 2. Oh, I did that backwards. Sorry. I was just looking at this and writing it down, and here we go. 1.5. There we go. Okay, so these are in terms of I2. That's great. So now all we got to do is plug these into this one. I2 is equal to I1, 5 milliamps minus 1.5 I2 plus 5 milliamps minus 0.75 I2. Right? That gives us 10 milliamps. And these are both negative, right? So 2.25 I2. Okay, and then so I2, 3.25 equals 10 milliamps. So that means we're going to have I2 is equal to 10 milliamps over 3.25. Now what does that give us? That gives us a value of 3.08 milliamps. That's the value of I2. So that's fun, we just found one. Okay, great. And then we plug that back into any of these other equations, right? So we have, plug it in here and here. Well, we do both. So that means that I1 is equal to 5 milliamps minus 1.5 times 3.08 milliamps. That gives us a value of 0.385 milliamps for I1. For I3, we're going to have 5 milliamps minus 0.75 times 3.08 milliamps, because that's I2, 2.69 milliamps. So those are the values. These are the three values of the currents that we were looking for. And so we found the currents, but it asks us to identify the current in each resistor, right? So I2, 3.08. I2 is going through R2, 3.08. I3 is going through R3, right? I1 is going through, sorry, that's not, I keep pointing to the battery. What I mean to do is I1 is going through R1. I1 through R1, I2 through R2, I3 through R3. So actually those are all, they're all labeled correctly.